Righty. I think I've got everything good on my end. If folks can just let me know if you can see and hear me okay, that would be awesome. Hope everyone's doing well on a Wednesday or possibly Thursday, depending on where you're located. Glad to see we've got, yeah, Scott McLean's always the first one in. Thanks for letting me know, though. I appreciate it. And we have two of our moderators on. So Amanda Joe is on there, and our good friend Susan Helmer. We're glad she's doing okay. She rode it out right through the brunt of Hurricane Helene and Hurricane Milton down in Florida. She's in the St. Petersburg, Tampa Bay area. So we're glad everything is good and okay for her. Very helpful. We'll get started here at 3, top of the hour, in about 10 minutes or so. But just to let you know the format here, we'll do some announcements, just kind of random things. It's been a month or so since I did a live stream, and I admit I was missing the interaction and having our community together. And so we will do some quick announcements. I want to show you some photos from the recent field trips I did. I did 2 rounds of field trip over the last few weeks. A couple things about Iceland. Amanda Joe sent me some interesting articles, and we'll look at the data a bit too. Bruce Garner has also sent me some of his very popular graphs and projections for when we might see more action on the Reykjanes. And then I think we'll devote most of our time to questions and answers. And I suppose just any topic or so is on the table. It doesn't have to be particularly about Iceland or anything like that. So let's see. So Tim here is from Canada. Just a few shout outs for folks that are jumping on the live chat. Hope you're doing well. Thanks for joining us. Elizabeth from the UK. Sandrine from France. Always good to see you. Elaine's back in sunny Tucson. Saw her a few weeks ago with her husband Ron. Came by and met them for dinner. Joe from Queensland, Australia. Good day. Jay Scott's there, of course. Let's see. AJ from Wyoming. Ida says good evening. Kay from Dorset. John Sykes looking for additional information on vitrophere from the Charlie Brown road cut near Shoshone, and gilsonite from eastern Utah. Basic textbooks do not include these. Yeah, I could probably answer questions on vitrophere. Gilsonite I'm not as familiar with, other than just the definition of it for the most part. Yeah, so throw your question in the hopper and we'll see if we can get to it. Let's see who else. We got Geology Grandma from Orlando. Rathlen from Northern Ireland. Fly by Wire from London, UK. Suzanne is, well, you're up early, Western Australia, 4:50 a.m. So happy Thursday to you. Hopefully it's a good morning. I suppose you guys are heading into summer, so it may already be light. I'm not sure how that works. Melinda Gaborno says aloha from Honolulu. Aloha to you. Anne is here. Leslie from New Zealand. Susie from Boise. Richard from Orange, Virginia. Yeah, lots of good folks here. It's great to see you all back here. Lorna, Janet from Devon, UK. Laura from Germany. Sharon wants to know any favorite local Icelandic travel companies for a May visit. I'll let Amanda Joe probably tackle that one. She probably has her pulse on some of the travel companies. She actually used to work for a travel company in Iceland, if I'm not mistaken. Scott is here from South Africa. Excellent. Camilla from Norway. And then my screen jumped down again like it always does because more people are jumping on, which is great. Shawn says 5x5. Oh, here we go. Scott, yeah, I got Scott. Camilla. Judith from Wisconsin. Susan Weimer from Florida. Jean Patrick in Munich says hi. Patty from Iowa. Tony from Leicester, UK. I probably butchered some of the pronunciations. I apologize. Charles from San Francisco. Laura in Shaking, Quaking, California. Hopefully not right now. Lori from Minnesota, Richard in Vienna. You have a beautiful city. We were there last March. Pam from Bitterroot Country, Wolfgang in Germany. Susan from North Central Idaho. Jackie from New Mexico. Laz says it's a very wet Lancashire. I never know how to say that. England. Julie from Maine. Just There for the Rocks is in Reno. Sharon's in New York. Sharon, thanks for coming out. Sharon actually works in New York City and came out for one of our field trips here in northern Utah. So that was pretty awesome and impressive. Greg from New Zealand. Kyle from Virginia. Ryuichi from Austria. Let's see. Mouse from New York. Good stuff. Dan from Pennsylvania. Yeah, we're getting quite a few folks in, which is awesome. Yeah, we'll get started here in a minute or two. I guess maybe 3 or 4 minutes as I look at the clock again. And there's kind of a rundown there on the screen of kind of what we'll go through. I think a lot of the time can be for you for question and answer. I don't have a ton of information from Iceland. Things are somewhat quiet right now, but building up. So we'll look at some of the data. Bruce Garner has some projections and graphs which are fun to look at, and I've got a couple news items courtesy of Amanda Joe. So we can kind of just see how this goes. I just wanted to do one because I looked and it had been about a month since we had done a live stream, and I also wanted to share some of the field trip photos and such. Okay, back to shout outs. Dan in Massachusetts, Ralph in Folsom, California, Michelle from the beaches of New Jersey, El Chufe from Amsterdam, Estrame from Iceland, awesome. Josh wants to know if GIS is important to learn as a geologist. Yes, very much so. When I was in school, it was kind of just becoming available, and I don't think, well, at least I didn't foresee how useful and mainstream it would become. So, but absolutely, I'd say in the last 20 plus years, it's a very important skill set to have. Let's see, how are we doing here? Rachel from Texas, hope you're doing well, Rachel. Brian E is in here. Danny from Geologically Boring Tampa. Yeah, but you guys have been on the cusp of severe weather news, right? So something a little different. Santa's Little Spatula in Kansas City. Some of you have like the most creative names. Mark's in Sweden. Christina's in Germany. Eighth Day says hello from Liverpool. John-Luc from Southern California. Colleen from San Jose. Yeah, go ahead and hit the like button. That's always helpful. Do all the good things to help promote our community and our channel. That's much appreciated. Shirley from Spokane. Kylie in Melbourne, Australia. A lot of you are just saying hi to each other, which is fine. Alan DeMars, thanks for coming out for my field trip. Alan's just up the road here in Jerome, Idaho. He could almost throw a rock and hit my office building. Yolene's in Bend. Pat's in Roseville. Aaron's in Albuquerque. Andrew's in Lincoln, UK. We got Tim, of course, from Toronto. Yeah, so they had the shakeout drill yesterday in California. That's where they practice earthquake preparedness by jumping under desks and stuff. Very important to do those sorts of things when you live in earthquake country. Tori's in Tennessee. Todd's in Provo. Hey, Todd. Very cool. Yeah, people from all over the place. Bavaria. Fritz46 from Bavaria. Very, very awesome. Good stuff. So we do have our moderators on here, friends, Susan and Amanda Joe, or Mandy Joe, as she will go by in the chat. They will help aggregate the questions, so just follow their directions and prompts on how to send your questions properly. They do have a procedure for that so that they can actually find and select those questions out of the live chat. So go ahead and send those in either now or as we go throughout this little session here. Yeah, I'll probably only take, I would guess, I can't imagine going over half an hour or so of just some announcements, showing you some of the field trip photos and giving you a few stories there, a brief Iceland update, and then we'll spend the bulk of our time here answering questions that you might have, doing my best to help answer, or answering together, right? A lot of times people chime in and know the answer to it more than I do, which is fine. This is a community. Everyone's welcome. We're all here to learn from each other. So that's the idea. My clock says 3 p.m., so let's go ahead and get started. Thank you and welcome to this live stream edition. I'm Geology Professor Shawn Willsey. Can't speak right now. And this is a special live stream broadcast, just getting our community back together, going over a few things that have happened with our community in the world, and then also spending some time answering any questions you might have. So appreciate you joining us. Make sure to hit the like button, and thanks for your support of the channel. There are moderators on here that will handle aggregating the questions that they'll send to me, and we'll try to get to as many of those as we can. But let's go ahead and get right to it here, team. A few announcements I don't have like a slide for, just sort of verbal announcements. I have been in touch with Johan at Nature Eye, and we want to do a flight soon. I know there's not an eruption happening right now, but I still think it would be pretty neat to fly over either any one of the previous lava fields from the last few eruptions, or I've been thinking about maybe flying over some new area on the Reykjanes, maybe looking at some of the older volcanic features. So Johan and I will look at the weather and look at our schedules and see if we can put something together. Realize, of course, as we're heading into the fall season in Iceland, that our window of daylight is fairly small and shrinking literally by the day. So we'll try to make something like that happen over the next few weeks. Other things of note on the channel, I'm actually running out of, usually I have quite a few videos in the hopper, but the well is running dry, so I need to get out there and do more videos, both field-based. I'd like to get some more interviews lined up with other geologists and people of interest. I'm even running out of random road cuts in the hopper, so I need to go out and get to some new road cuts and shoot some more videos. I'm excited to do that though, because I just purchased a new camera and I'm really excited to test it out. I had been using a simple GoPro camera, which really worked fine. I think it was okay. But it wasn't really designed for what we're doing. GoPros are meant for, fast, rapid sports type motion, and not really the best instrument to use for like zooming into rocks at a road cut. But this new camera I'm excited about, because even if I move it kind of quick, it has a gimbal, and so it actually pans slower. So many of you will appreciate that, because I'm notorious for moving the camera too quickly. I've even had viewers say, hey, your stuff's really great, but I get nauseous watching your videos and I'm out, and I totally respect that. So hopefully a better camera and a little bit of patience on my part will result in a little bit better optics and visuals as we look at some of the videos. And I'll continue to work on those Geology 101 videos. Many people seem to like those. It's a good either refresher or a good foundation if you're interested in geology, but you're kind of just picking up things along the way and you've never had a chance to kind of go through the basics from start to finish. This is a good way for you to learn some of those concepts that'll make you, be able to not just understand geology better, but when you get outside and do your own little adventures and stuff, you'll be able to apply that knowledge to the real world and be able to basically be a competent geologist, which would be great. So just kind of a debrief on some of the field trips I did. So I did 3 days of field trips at the end of September down in northern Utah. So I just wanted to show a couple of the photos that were taken from that. I didn't take a lot of photos because I was busy answering questions and kind of running the show, but I did have a couple of viewers that shared some of their photos with me, so I appreciate that. You can see the beautiful fall colors there up Little Cottonwood Canyon, some of the just beautiful rocks and scenery there in the Wasatch Mountains. So we spent the first day, Friday, up in Little Cottonwood Canyon looking at the glacial history, looking at the history of thrust faults shoving rocks over the top of themselves, the granite at the base of the canyon. This is actually a group photo of our crew from the top of the tram. So we rode the Snowbird ski resort tram up to an 11,000 foot peak. And this is the crew we had for the day. So looks like we're just standing in a parking lot, but we are actually at a quite high elevation right there, looking, I suppose, there to the northwest with some of the big Wasatch Peaks there behind us. So pretty good looking crew. Everyone seems to be smiling. It was a great day, great weather. This is some of the scenery. This is looking at Hellgate Cliffs as we're coming down. Most of us rode the chairlift down, which was pretty sweet. And you can see some of these Mississippian limestones here with some of the quartzites and other rocks that have been actually shoved over the top, these beige rocks here. But I will repeat all these field trips going into the future. So if there's something you see here and you think, oh boy, I wish it could have been there, or maybe maybe you have friends or someone that lives nearby or a reason to be there other than just a geology field trip, I will repeat these field trips for the foreseeable future until everyone's just exhausted and everyone's kind of done them, I suppose. So great to do. It was great to meet with folks. On Saturday, we went out to Antelope Island, which is a fantastic island in the Great Salt Lake. It's kind of a warm day, especially for late September, but everyone did fine. Everyone was a trooper. You can see some of the prominent shorelines there from Lake Bonneville behind the crew there. So we walked out to Unicorn Point, which is the south end of the island. And I think Julie, one of the folks there, took this fun panoramic shot of us all sitting around and discussing these interesting rocks here, these rocks that were high-grade metamorphic rocks that actually partially melted and were at least part of the way towards being a igneous rock when they cooled and solidified. So beautiful scenery there at the south end of Antelope Island. Then after lunch, to get to these amazing rocks that show part of the snowball Earth story, this period of seemingly global glacial conditions. The closest and easiest outcrops to access were about a 500-foot hike up the hill, and it was quite warm. So we had a few folks struggle a little bit, but most folks made it up here. So that's looking out over I guess to the east or southeast. You can see the Wasatch Range in the background. What's left of this part of the Great Salt Lake behind us there. This goes towards like Farmington Bay. You can see the little road down here that snakes out towards the south. And then up here we are on top of these diamictites, these big crazy glacial till deposits. And then it's capped by this carbonate, this dolostone sitting up here. So everyone looks riveted there, checking things out. So this was Antelope Island, and then we rounded out the day over at Buffalo Point, looking off to the west side of the island where the lake is much more impressive. You can see the Stansbury Range and island out here. Shorelines, again, pretty prominent in that area. Then on Sunday, the field trip was from Ogden Canyon, which is north of Salt Lake City, up and to the east to Echo Canyon. And this was a field trip I think probably most excited for because it was a new one for me, although parts of it I'd done before. And this was sort of a transect through the severe orogeny, a big mountain building event that occurred about 100 million years ago. So we were going to go from the guts of those mountains where the rocks were deformed out into the basin deposits that were shed off of those highlands about 100 million years ago. So here we are in the parking lot, kind of getting oriented, giving everyone a little idea of what we're going to see. And then we did a walk up into Ogden Canyon. So there's most of the crew there looking, I guess, to the southwest at some of the quartzites and limestone up on the ridge here in Ogden Canyon. We later in the day got over to Echo Canyon. We're skipping quite a bit here, but this is just sort of the highlights and the pictures I have. And these are some of the basin deposits here. So you can see these big conglomerates, these big rounded river rocks that were shed off of these large highlands that are now eroded away. And so this is where we concluded the day. Actually, it was nice because it was getting a little bit cloudy there and wasn't quite as warm. And we had people from all over the country, mostly the western U.S., but if I remember right, we had Sharon from New York, people from Michigan, I think, on this trip, Kansas City, if I recall correctly, as well as a lot of western states. And then this past weekend in October, I did 3 field trips around Twin Falls here in southern Idaho. This is our Friday field trip out to Craters of the Moon National Monument, so looking at one of the big lava tube tunnels there with some of our folks checking out the features in the lava tunnel. Here's Craig from Colorado in one of the sections of the lava tube. So very cool environment here, one of my favorite places. Saturday we went out to the City of Rocks, which is a national reserve, part of the national park system. Some of the granite that you see there, there's fins and spires and hoodoos of granite that stick out of the high desert environment there. We've got, let's see, Ernest and Clara from Spain by way of Quebec that were there. I think we had a couple from Michigan and all over, just people from all over the country, which is really cool. And everyone gets along well. The field trips are just, every time I do them, I'm like, this is more about them being together than anything geologic. This is another picture from City Rock, some of the cool cross-cutting relationships here. This is this darker rock here is the 2.5 billion year old granite that some of the oldest rocks in Idaho, part of the Archean craton in this part of the world. And then this younger rock that is intruding it is 28 million year old granite that cuts through it, a different crystal size, slightly different chemistry, and you can see some of the exciting contacts there. So just really cool place. And then the last day, real quick, to round this out, was on this past Sunday. We went to the Little City of Rocks, which is a totally different landscape, totally different rock types. These are related to the Yellowstone hotspot and these very hot, very intense and large volume pyroclastic flows that actually remelt over time. So there I am yapping away, telling them some great things about that. And then we ended up that day in one of my favorite places, the Black Magic Canyon. It's a riverbed that's been carved out by hard gravels of chert and quartzite, and the bedrock here is all basalt. It's about 50,000 years old, and it was diverted into this location about 11,000 years ago. So it's pretty cool to see this kind of slot canyon landscape form in such a relatively short period of time. There's most of the crew there, just over this first kind of dry fall pour over there, and you can see the sculpted and fluted rock there in the foreground. So pretty neat. So those are the field trips. That was the last field trip for this year. Looking ahead to next year, I've got some big trips, and then we'll do, of course, the regional trips. Some of the trips to these places are filled up. I guess the next one, if you're interested, I haven't got the dates yet from the river company, but river trip in July 2026. I should get that launch date probably by the end of this month. It's going to be in July for sure. I just don't know what day it will start. And I think I can fit 17 on these These are private chartered trips with an outfitter along the river, 6-day trip through Grand Canyon National Park. It's absolutely spectacular, and I've showed pictures in previous live streams and such. But if you have any questions or you want to get on the list, you can email either myself or Amanda Jo through the website, and we will put you on the list. And then once it's open and available, I can funnel you to the river outfitter, and they can get people's deposits and get them signed up. Some of these smaller regional trips, like you saw here in Idaho and in Utah, I'll do those again next year in 2025, but I don't have those scheduled just yet. So just keep looking at the website, keep looking, at videos and stuff, and the website will be your best notification for those trips. But probably by, but definitely I would think by maybe just after New Year's or so, I should get at least some of the spring trips organized. They're just a lot of fun. They're just, I think it's the best way for us to learn geology together is through these field trips. So, of course, I know that you guys are in different places, and for some this is much easier than it is for others that are in Europe or Australia or Africa. So, yeah, maybe one day I'll have multi-continental field trips, and that would be great. But for now, that's sort of what we're doing. Okay, so switching gears here a little bit. I did have some stuff to share on Iceland, so let me pull up my Iceland information to share with you. Basically, what we have going on in Iceland is we are basically recharging the system. The magma body is still filling with magma that's accumulating from depth. And we are slowly but surely, day by day, building towards some future event. Most likely late November through Christmas time would be a pretty good time frame. Somewhere in there is the most likely at this point estimate of when we might see another eruption. Of course, all the big questions would be not just when, but where. And realizing that we've had these past eruptions in different locations. We've had the December eruption, and just kind of running through the December, the January, the February eruption, the March eruption, the one in May 29th, and then the most recent one, which was further to the north and began on, oh, whoops, now it's all frozen. I overloaded Google Earth. And then the most recent one that began on August 22nd at this northern end here. So it'll be interesting to see where we see this thing erupt, and I think we'll see some sort of signal. It might only be a few minutes before, an hour or so before the eruption begins, but those earthquakes will be probably the most revealing piece of data as to where the eruption might occur. But for now, things are pretty quiet on the peninsula, and we haven't seen a whole lot of earthquakes of note. Of course, the earthquakes are not to be expected because we have a lot of space for this magma to accumulate, and we only really see earthquakes around this eruption area when we have a filled system and that magma is actively pushing on and breaking and fracturing and shifting and moving the rock. That's when we see those earthquakes really ramping up. And right now we're just in this very slow pattern. So there's the past week or so, looking at the last so that was the last 24 hours. Looking at the last week or so throughout all of Iceland, you can, of course, pretty well trace the plate boundary as it works its way through Iceland just by looking at the earthquakes. There's been a few larger quakes here and there underneath some of the ice caps, but nothing at all so far that suggests that any of the other volcanoes are, rumbling, or that there's any significant magma migration in any other part of the system. So for now, we're focusing mostly on the Reykjanes, but we're of course keeping an eye on all of Iceland's volcanoes. And again, just right here is where we've seen our last year or so of eruptions, and there's just not a lot going on there. A couple over here in the Fagradalsfjall area, and then a little bit out here in the Krýsuvík system. But otherwise, earthquakes pretty quiet, as you might expect. GPS is where we see the most sort of steady day-by-day motion and movement of the system. So real quick, if you're new, this is a GPS plot, actually 3 graphs for a given location. So this location is right near the power plant and the Blue Lagoon. 3 graphs here, one that shows the north-south movement of the station over time. So you can see the months here, July to October. And if the trend is upwards, that's northward movement. When the trend is downwards, that's southward movement. The middle graph shows east-west motion, so up is towards the east, down is to the west. And then the final plot on the bottom shows up, down, or vertical motion, with the dots trending upwards being upward or vertical motion in the up direction. And if the dots are lower on the graph, that would be downward motion. And so you can see this big change in the data here right at August 22nd when the last eruption took place. And since that time, if we just focus on this bottom graph here, we've seen a pretty steady uptick. Day by day it fluctuates a little bit, but there's a nice more or less linear trend there to this data showing that the magma is inflating, that there's more magma coming into the system. That inflation of magma is causing the ground to rise slowly but steadily, and we'll see where this goes. Ideally, we need to see this position here at this GPS station at least meet, and if not exceed, the highest elevation we saw in prior to the August 22nd eruption. So the GPS data just continues to kind of move along, similar to what we've seen in the past, and I'll make sure I put links here when we're done to all this data if you're interested in kind of digging into and looking at some of this. Another way we can measure ground deformation is with the INSAR data, basically satellites passing overhead, bouncing radar waves off the ground on one pass, doing it again on another pass, and then measuring the difference. And so you can see the little bullseye here on the Reykjanes Peninsula. And this was a pass from October 1st to October 13th using the Sentinel-1 satellite. It's all right, my office phone just rang. And let's see if there's another one. Yeah, there's a nice one there with the Terasar satellite data from September 28th to October 9th. Again, so these little fringy rainbow psychedelic colors here indicate uplift. I think it's something like 1.5 centimeters per color band. So when you see a full color band, you're looking at about 1.5 centimeters of upward movement. So for example, from that purple to that purple, or I suppose if we go from green to green to green, then you're looking at maybe 3 to 4 or so centimeters of uplift during that time. So the uplift or ground deformation GPS and the interferograms seem to be showing that most readily. Let me switch over to my email here and show you what our good friend Bruce Garner's been looking at and producing for us. So he sent me an email pretty recently, and as many of you may know, he's been kind of keeping track of this with his own little data analysis and sharing that with us, and thank you to him for doing that. I think it's been a fun addition and given us some different insights. But what we have here is a graph of this specific GPS station, the Svartsengi station, since last October. So this is this is a year's worth of data. So you can see it not moving at all. And then in late October, this was the first signs we had that magma was starting to move into this region. So we have this steady uptick, and that all reached a head on November 10th when we had a flurry of fairly strong earthquakes. This is what evacuated the town of Grindavik, and this is exactly what we thought was leading to an eruption. We thought an eruption at that point was basically imminent and going to happen at any moment. Of course, it didn't. What really happened there was that magma moved eastward and accumulated in a vertical or semi-vertical dike, a conduit to store magma, but it didn't quite make it to the surface. And then magma continued to accumulate, so the station continued to rise, and then that culminated with the December 18th eruption. Magma continued to accumulate after that eruption was over. Then we have a little hiccup here for the January 14th eruption, which was further south. That's why it's not as big of a spike on here. Then we had the February 8th eruption, March 16th, May 29th, and then the last one here on August 22nd. And since then, we are right about here. And so Bruce is kind of using the rate or the range of rates of accumulation, and then these pink lines are his projection lines to see when the next eruption might occur. And he's using you can see each one of these little stair steps goes up higher than the last, so he's sort of calculating an average increase. Each time we get one of these magma accumulation events, the system's able to heat up a little bit more, stretch the rock a little bit more, make a little bit more space for itself, and consequently it takes more uplift or height in the system to trigger the eruption. So his elevation estimate is shown here by the red bars, and he has us getting to that point somewhere in late December to just past New Year. Somewhere in there is Bruce's model's best estimate of when we might see an eruption. Could be sooner, could be later, and he continues to kind of adjust the model based on the data that's coming in. Let me make sure I look at his email and kind of capture all the rest of it here. Yeah, so and then he sent it me several graphs. I don't know if we want to cover all of these per se, but this is this is with several stations. So you can see the 4 different colors at the top, 4 different GPS stations tracking the uplift since the March event. So there's everything trending up. May 29th, there's that eruption there, and then everything starts tracking back up. until August 22nd. There's that eruption there. There's a little hiccup here, he says, because there was some sort of processing issue in the GPS data, so there's a weird little spike here. So that's probably not real. And then you can see everything kind of going up. Anyway, kind of interesting to see the data plotted that way. Some of the stations. This is just a plot of all the earthquakes. This is a 7-month view of daily earthquakes, including the buildup to the last 2 eruptions. So you can see the earthquakes coming in, but a lot of these again would be the earthquakes, right before, within, the days or hours preceding the eruption. We can see some of the bigger circles up here at the north end. This is from our last eruptive phase in August. Remember that this opened up to the north. We had extension of the fissure system to the north, and so to accommodate that magma and move it further north, that required breaking rock, and so you see quite a bit of earthquakes up in this region here. And then finally, his last cool graph here. This is total number of earthquakes. Let's see, since March 19th going up till basically today. So you can see the earthquakes here in late March and April. You got one little spike there, but basically you can see this kind of build up here, kind of a weird lull, and then boom, that big spike there. That's the day of the eruption. Then everything drops off because the volcano is actively erupting. And then we start building back up, and then the big spike here is the eruption on August 22nd, including, you can see that little red there, that was a magnitude 4, so one bigger event. So this is just total number of earthquakes. This does not necessarily reflect the energy of the earthquakes. If you looked at the cumulative energies, I think you'd find them probably pretty comparable. And so you can see we're in this lull right now, right? Everything's pretty low. We're sort of in this phase right here, so we're likely looking at least 6 weeks or more until we get to that next level there. So thanks to Bruce for sending that. Very, very cool. Let's see. So a couple other things related to Iceland is, let me grab my other thing here. Great news. So this was a big surprise, and thanks to Amanda Joe for sending me some of these Icelandic news stories. But the town of Grindavik, which has been off limit to tourists, which was evacuated on November 10th, almost a year ago, and has been off limits to visitors and tourists and only accessible, and even then it wasn't even accessible till, I don't know, February or March, something like that, to residents. They're opening the town back up. They still have fencing. There's still a hazard there from the fractures and the cracks and all the damage from the earthquakes, but they are going to open it up starting this Monday at 6 a.m. So that's great news. If any of you are going to Iceland or already there, I guess the best thing I can encourage you to do is to go there and maybe look, visit some of the businesses, make sure that we're taking care of those local businesses in Grindavik. Please be respectful of any closed areas and of course the residents that live there. There's the obvious attraction, I think, when we're visiting a place like this to want to just go and sort of just gawk at it and look at it, but these are people's homes, these are people's communities, so just be respectful. But for the most part, I'd say, I would assume they would encourage and like to see folks coming into the town and supporting some of those businesses. So little article there about that. And then the biggest danger, of course, in the town are the big cracks in the ground, but they're fenced off, and so I think they're a little leery because they're hopeful that no one gets hurt. I think that they talk about, like, children and stuff, unsupervised children. There could be a little bit more risk, so we encourage people not to bring children, it says here. So yeah, just being responsible for your actions and being respectful, and looking, of course, but not presenting any risks to the people in the town. So great news there. Similarly, kind of looking also at Grindavik, was this article here about they've also had all this time since the last eruption to continue to work with the heavy machinery and build up those defensive berms around the town and the power plant. And so those have been fortified, probably heightened in some places. Basically, it says they're ready. The fortifications are ready, and they've moved 2.7 million cubic meters of material, and the project manager thinks that's a record. And yeah, why not? I've never seen anything like this in modern times, certainly, to have this much material moved around and have this much effort put into lava flow mitigation with the power plant in the town there. So it's really, I wonder if, years from now, and even maybe a year from now, if this will be like a great case study for how a community was able to deal with and actually thrive with this apparent volcanic threat. So pretty cool. So that is one story. And then my final story here to share with you is in my last update, I talked about the airport. And I did get one piece of information wrong, so I want to correct that. I wasn't quite sure. There was some discussion amongst Icelandic officials about building an airport in this region here, about halfway between Reykjavik and the Keflavik airport. And I assumed, and I was wrong, that maybe they were looking to build a new international airport. Well, what they're actually trying to do is basically this regional airport, which is right in the middle of Reykjavik. It's noisy, there's houses around here, there's potentially some safety concerns, and so there's been a proposal, and I don't know how far up the ladder this has gone in terms of like, is this going to happen, or is this just an idea that's being discussed? But one idea was to abandon this regional airport, and then this obviously could be reclaimed for residential or commercial property here, and then put in instead a regional airport somewhere over here. And then eventually they talked about even linking everything with like a high-speed rail line, so that you would get off your international airport flight, jump on the high-speed train, which would whisk you right into downtown Reykjavik, which is where most people go right when they get off the plane. And then people that had flown in on the domestic airlines would get off at the regional airport, which might be somewhere in here, and then they would have that same rail line there. So anyway, the article, there was obviously in my last update, and I'm sure in the Icelandic press and in other places, the big concern, of course, was this was the site that some officials had somewhat targeted. And you can see here, even to a non-geologist, there are older flows. I'm not sure how old these flows are, but not that old, that come down right into this area. So from a volcanic hazard standpoint, that looked like a pretty lousy idea. And so they've sort of gone back to the drawing board, and they're basically, the article says, we haven't decided anything. We need to like weigh all our options and keep every possibility open. Yeah, so it'll be interesting to see where this ends up, if they actually end up deciding to fund, and they fully have committed to putting in this new regional airport, and two, where they actually decide to site that airport. So interesting stuff though, and thanks to Amanda Joe for sending me those nice bits of news items. She's quick with the computer. She can send me an email with 20 links to local news stories quicker than I could probably find one or two on my own. So thanks to her for that. I think that's all I had on my list, if I'm not mistaken. So with that being said, let's see if there are any questions I can handle or tackle. Happy to help with whatever I can. So if Amanda Joe send me maybe the first page of questions, that would be great, and we can address those. I feel like I'm forgetting something. Iceland, field trips. Maybe not. Someone will remind me if I did forget something. Yeah, so it's great news, just looking at the live chat now, great news that the town is opened again. I've been thinking too about, like, let me get rid of some of this is messy. We're almost on that anniversary, and that November 10th, that's the line in the sand. There was a lot of things happening prior to November 10th. Things were ramping up. If I remember correctly, my first video on Iceland and this whole event was on November 3rd. And for many of you, that's how you probably found me. I know a lot of people started watching the channel beginning with some of those early November broadcasts. So I don't know, I'm not saying we need to have a party or anything, but it is great. I think if there is anything to celebrate, it's the fact that the town's opening about a year or so later. So I think that's great news. Okay. Great. So I've got my questions here from Amanda Joe. Oh, Tim wants to know what camera I got. That sounds like Tim. He knows his cameras well. So the camera I purchased, and to let you guys know, I've been looking for a camera for a long time, but I don't know much about cameras. I'm not into optics. I want something simple. It's like I know what I want, but I don't know how to find what I want, basically. So I ended up talking to Myron Cook, who many of you know also has a geology YouTube channel, does a great job, and he told me what he was using. It's called the DJI Osmo Pocket 3. Here's what it looks like. I'm going to actually use it tomorrow. We're having a big storm blow in tonight, and so it's going to be windy tomorrow, so I'm going to take it outside and test out like the microphone and such. So I don't know if you guys can see this. So it's very small. It has a gimbal on it, so when like I move it quickly, it actually kind of keeps things smooth. There's even like a face tracking thing, so if like me or someone else is in the frame and they're moving, it kind of follows them. And maybe not most importantly, but helpful to me, it has a zoom, so that when I'm on those road cuts or whatever, it does have a bit of a zoom where I can zoom into the rocks and show you some of the details. So there you go. For Tim and others that are gadget geeks and interested in that, I'm hoping it is it's got a little handle to it, just kind of like a selfie stick. Microphone with the little dead cat wind thing on it. Extra battery. I think there's another lens, like a wide angle lens that goes on it. All sorts of fun stuff. Really good. So DJI, and they make drones too. I have one of their little mini drones that's pretty cool. Okay, that was Tim's great question. Dan wants to know any new earthquake activity around Mount Adams. I've been checking on that. I did a video not too long ago about Mount Adams. So Mount Adams is a volcano, a stratovolcano in the Pacific Northwest, right, and cozied up next to Mount St. Helens. And I've been checking, and I guess the short answer is not really, or at least last time I checked, there wasn't any significant. Let's see, let's go back 7 days or so and see what we've got. So yeah, I think it's still, so here's, sorry to zoom in and out so much. Here's Mount St. Helens over here. Here's the past week of earthquakes. So you can see 36 earthquakes are shown on this map. And it looks like 35 of them are over here by Mount St. Helens with just one sole magnitude 0.2 quake that happened yesterday on October 14th at Mount Adams. So even though it's not a lot of earthquakes, if you've been watching Iceland volcanoes, you're like, why is this even like any sort of a news item? Well, Mount Adams hasn't had, any earthquakes basically. It's like one per 3 months or something, and then all of a sudden we got 7 or 8 within a month. So it's a significant uptake. It's not a big number in terms of the total quantity, but it's a significant deviation from what we've been seeing as the background noise there. And so, yeah, so I've been kind of checking every so often. There hasn't been any additional press releases or information from the USGS, and so it's just sort of is what it is right now. But they did put in some new seismometers in the area, so now they've got a little better ability to detect those earthquakes. So we'll just kind of have to see moving forward how things go. So thanks for the question, Dan, and I'll just kind of keep watching that as best I can. From Fred Gars, will there be a field trip to Iceland this spring? No, I'm kind of booked with that for now. I'll try to continue to do a field trip each year. If you are interested in being a part of that, the best thing you can do is email myself or Amanda Joe through the website email. She'll get all those emails to me that I need to, and then I at least have a list of interested people to pull from. So there will be a trip, but that one is filled so far. Thanks for your question, Fred. From Karen Lovelace, have been you able to watch Nick Zentner and Hannah Shamlu, who were checking out some goat rocks last week, they were wondering about people who rappel climb. It looked like a really cool place. Yes, I actually did see that video. They hiked in to this incredible big cut showing lots of layers of tephra, ash, and different types of volcanic layers. It did look very cool, and so I did check it out. If I was closer, I would love to volunteer my climbing skills and expertise and actually help them and be able to rappel down and look at some of those layers with them. That would be an incredible opportunity, but alas, I am 10 to 12 hours away by car, so probably not going to happen. From Daniel, I know this is not geology related, but did you get to see the Northern Lights in Idaho? They were spectacular in Massachusetts. Yeah, doggone it, it was cloudy. You know, it's been clear and like no clouds in the sky for like literally months on end. But the 2 nights that the Northern Lights were visible here in Idaho, we had some clouds. That being said, I've actually seen the Northern Lights before. Many years ago, my wife and I went to New Hampshire, and we were able to see them. And so they're quite a treat. So I would have loved to have seen them, but we missed out because of the clouds. From KTM Gurley, she was sent a photo of a rock, or they were sent a photo of rock. I tried using your videos to identify it. To me, it looked like feldspar stuck to sandstone, but is there a story that could lead to that, or did I just guess wrong? You shouldn't have. So feldspars as crystals will be in your igneous and metamorphic rocks. In a sandstone, they're going to be broken up grains, right? So you have to kind of think about the environment. So if you're pretty sure you have a nice rectangular or square shaped feldspar crystal, then you probably don't have a sandstone. You probably have a igneous rock or possibly a metamorphic rock. So, but yeah, best thing I'd say is, you know, if there's hopefully a college or university nearby or some folks nearby that have some geology knowledge, maybe take the sample to them or send them a picture of it and see what they think. So so you might be right on the sandstone, or you might be right on the feldspar, but based on what you're telling me here, I'm not sure if you're right on both of those, because that's kind of a weird situation to have those together. Okay, next question from Basti K. You come from the desert. That's true. I do. I was born in Phoenix, and I've lived in the desert environments most of my life. What is the best place to learn about coarse sandstone fossil preparation? Not for me. You'd need to talk to a paleontologist. I don't know specifically what kind of fossil you're looking at there, but fossil preparation using air scribes, having good ventilation is very important. Yeah, I would contact, again, a college or university nearby if there's any sort of, if you had like a fossil bed, like National Monument nearby with a paleontologist there, you could ask them, and they might be able to help as well. VIBC Outdoorsman. Wow, we've got questions coming in from like, this is a random group of questions. We've gone from cameras to Mount Adams to Iceland to Northern Lights to rocks someone found and fossil preparation. Here's one that's even more. I'm not going to know the answer to this one, but VIBC Outdoorsman. What are the 5 microplate names of the larger Farallon plate? Could it be possible that the Explorer is a remnant of the Resurrection plate? I have to admit, I don't follow those tectonic stories as closely as others and many of you that watch Nick Zentner do. So I'm going to claim complete ignorance. I mean, I know a little bit, but I don't know enough to answer your question or to speak knowledgeably about that. So apologize for that. Wolfgang says, I know nobody knows, but what would you expect where the next eruption might occur, more northerly or back to the south, and why? Yeah, we can spitball this a little bit. Trying to couch this in the best possible terms. I think if I had to take, I think we've got three possible scenarios, and the Met Office has said as much as well. Basically, we have 3 regions where we've seen eruptions here in the Sunnukurgiga system. I probably butchered that. We have the area where we've seen most of the eruptions occur in December, in February, in March, and in May. So like these are all pretty closely constrained between, just east of the power plant, south of Stora Stogafeld, and just to the east of Silingerfeld. So this is zone 1, you could say, of where the system erupts. There was or is a plumbing system and a conduit to the surface. Then we have two, at this point I guess we could call them two anomalies. The January eruption, which was much further to the south, including the little fissure that opened up right by the houses and took out 3 homes. Thankfully, all the eruptions after January didn't reoccupy this conduit or pathway. So that's one anomaly. And then, of course, we have this August 22nd eruption, which extended the vent area to the northeast. And then we had this spatter cone here that was sort of the most long-lasting of the bunch. I'm really not sure. I think the chances of it being at the south end are low. So I would say that's my dark horse. That's less likely to occur. I would put it sort of even odds. Again, this is all just a lot of guesswork, that it's either going to be this middle area or potentially back to the northeast. I would put those at kind of even odds based on what we've seen so far. So no one knows for sure. That's, that's my, not even a hypothesis, it's mostly a guess. So, and please don't tell someone I said that in writing, because I certainly didn't. So, okay, good stuff. Let's see, where are we at? So that was question page number 1. Hopefully that was pretty decent. And then, Manda Joe, if you want to send me another page of questions. I kind of like that we're all over the place. Like, I'm fine. I know a lot of times we do these and we have, Iceland is the topic, and so we try to stay on topic and keep things centered around that. But yeah, it will be in the dark. Yeah. Oh, you're placing your bet on the dark horse. I see. Yeah. Here's my big bold proclamation. The next eruption in Iceland will most likely happen in the dark, like at night, which of course is very obvious because we're heading into winter and the number of daylight hours are very short. So good chance of that. Not ground shaking information there. Yeah, so I kind of like that we're a little bit all over the place with our questions. That's fine. And yeah. So yeah, Amanda Joe, if you want to send me the next set of questions, if you have one, and then we can kind of go from there. Hopefully everyone's doing okay. We'll do another page of questions or so. Yeah, we've been going about 45 minutes or so. Hopefully everyone's doing well. Got a good number of folks here. Okay, she just sent those questions over, so they should pop up any second now. And there they are. Email, pretty quick. Much quicker than Pony Express times. All right, so question sheet number 2. Our first question comes from Heidi Monk, who, as a side note, I went to college with at Weber State. We were both in the geology program. Why are some of the eruptions a light gray color and some of the eruptions black in color? Is it a trick of the light, or is there some difference in chemical makeup? Heidi, I'm not sure if you're talking about the color of the lava, or you're talking about the ash or gas that's coming out of the ground. So I guess I need a little bit of a clarification there, if you can chime in. Why some of the eruptions are light gray color and some are black in color. And maybe you're speaking more broadly to not just Iceland eruptions, but eruptions in general. If you're talking about eruptions in general, it would probably be compositional. So basalt eruptions like we see in Iceland, or at least the ones here on the Reykjanes, high iron concentrations, low silica, they're going to tend to be darker. The ash may even be darker in color, versus if you have a Mount St. Helens type of eruption where it's going to produce lighter gray ash and lighter gray rocks. So it could be compositional. So if that was your question, that would be, oh, I see you put there lava. Oh, so why would some of the eruptions light gray lava and some are black in color? Yeah, lighting could be a big part of it. So a lot of times, lava flows, if you're looking at lava flows in broad daylight with the sun out, it's going to be lighter in color, and you won't see the incandescent glow if that lava is still molten that you might otherwise. Obviously, that's why a lot of the drone pilots and stuff will do their flights, early in the morning or kind of later towards dusk, because they're getting better colors there. So I think it's composition if you're talking about recent lava flows, or excuse me, I think it's lighting if you're talking about recent lava flows. If you're talking about when we look at like Google Earth, for example, and just kind of scan the landscape and find places where there's dark lava flows, and then places maybe something like this where it's a little bit more gray. If it's Google Earth you're looking at, it could be when that data, when that aerial flight was processed. And I mean, look right here, there's this weird light gray patch. I think that's more the Google Earth imagery than that is real. I don't know that for sure, but that would be my hunch. So you can see this weird gray blob here that just doesn't make much sense. So yeah, hopefully that's helpful. But if not, we can discuss further. Tim wants to know, according to Johan at Nature Eye, some geologists think that this Iceland area might turn into a shield volcano. Wrong magma type, right? Well, we can get shield volcanoes here, and in fact, we have shield volcanoes here. So if we look right here northeast of Grindavik, here is a lovely, and I don't know how old it is. So here's our recent eruptions, right? I don't know if I want to add all of these. It's kind of obnoxious. But there's all the crazy eruptions. Notice they're flowing around this feature here, which has a summit crater, a little sunken area here. And if you actually were to see this, I don't know if I can get low enough with Google Earth to kind of show the profile view. Probably not. But this is basically a broad shield volcano, which has some of these younger flows lapping up onto it. This little weird thing here, this is probably a lava tube system that has collapsed. So this was draining out from the summit area, maybe out into this area here, but you can sort of chase these craters and pits and channels right back up to the summit there. And so that is a shield volcano. So there are shield volcanoes here. In order to get a shield volcano here, though, we were going to need to have a longer lived eruption. These little 1, 2, 3 day, 1 month, even a 2-month eruption of these fissures is producing some nice little spatter cones, some nice volcanic features, but it's not producing a shield volcano. So you're going to need to have the fissure consolidate into one cone, like the spatter cones we've seen, but then we're going to need it to go on, not to erupt necessarily every day, but on and off pretty continuously for months, maybe a year or more, and then you can actually get some of these shield volcanoes forming here. So it is the right magma type, Tim. It's basaltic magma, and that's what makes shield volcanoes. But we just haven't seen the right duration so far. And if this little one here kind of makes sense, and if you can kind of just remember what this looks like, right? It's kind of broad. I wonder if we could do, let's try something fun here, team. Shoot, how do I do this? Oh, I know how to do it. We are going to do a transect across this thing, and oh, I have to do it as a path. Never mind. Okay, so let's do it one more time. What I'm trying to do here is show you the profile shape of this thing. Whoops, that's not what I wanted to do. I want to go all the way across. So let's clear that out. I thought I had to do points. Well, and I didn't quite go right there. All right, third time's a charm. Nothing as fun as watching someone else struggle with Google Earth. Okay, there we go. So it's not perfect here, but as you see as I go across this area, am I blocking it? Let me get my face out of here. There we go. You can see it kind of rise up. I mean, classic shield volcano shape, right? And then it kind of comes back down this side. So it's kind of broadly dome-shaped like this. And it's not maybe perfectly textbook, but it's quite close. Anyway, so if you can envision that place there, let me rush you across the Atlantic Ocean and closer to home and show you another feature that looks very similar and yet is very, very fresh in terms of how it looks on the surface. I don't know how old that one there in Iceland is, but let's head to my adopted state of Idaho. And here I am in Twin Falls, and we're going to go up the freeway here and get rid of the roads and look at this here. And here we have, I wonder if we should we try to do the little thing again, the little elevation profile. We'll start out here and go to here. It's a little messy here, but you can see it kind of rise up. Once you get to the top, it goes up and down a lot because there's some collapse features, but then it kind of just goes back down. So the broad profile is still kind of there. And more importantly, what I wanted to show you here was the similarities with this and the one in Iceland. So the crater at the top is a little messier, but here's your collapsed lava tube system, which looks very similar to what we saw over in Iceland. And this lava flow here is 11,000 years old. And this thing went across, and it went into the Bigwood River, and then it turned and went westward. And you can see the leading edge of it right here near this town called Gooding. So you can see the full extent of this thing right here. Pretty cool. Anyway, we have lots of these shield volcanoes here locally where I live. Okay, Tim, hopefully that was a good answer. Okay, next question. Estrame, do you have any idea how far south and north the intrusion/eruption fissure from the last year can extend before the eruption moves to another location? Well, that's a really great question. Let's just head back over to Iceland. So how far, remember that when we had on November 10th, the Met Office put out this thing, right? And this is my best, closest sort of reconstruction of this. The November 10th intrusion we thought was about 15 kilometers long and more or less followed this trend here. May not be perfect, but something like that. So your question is, how much further to the north and south can it extend? Well, we've only seen the eruptions in terms of a southward direction be about here, and I realize that's not right on the orange line there, but it's pretty close. So we'll just take the orange line out here in a second. And then at the north end, we've seen them extend right to here, just a little bit beyond that orange one. So if this orange line is to be believed, and if I located it properly, both of which have some error in them for sure, then that would argue that we'd seen pretty much the furthest extent. Remember, though, that just because the intrusion is there doesn't mean you necessarily have the plumbing system to get the magma from the intrusion up to the surface. That's going to necessitate earthquakes. It's going to necessitate breaking rocks, which we saw with the August event, and that's why we saw so many earthquakes up on this northern section. Of course, the big fear back in November, and I suppose still today, although I guess we're a little bit more confident it might not happen, is that this thing extends further to the south, which brings it right through the town. And that still is a possibility, albeit, you know, I think it's less likely versus what's happened in the past. So, yeah, how far can it extend was your question before it moves to another location? I think all we can really go on is like what's happened in the past, potentially. I think this thing potentially could extend further to the south into the ocean. It could extend further to the north towards the road, the highway here, without it needing to jump to some other location. It's just a path of least resistance. And so, you know, I think we're not going to see it move from here and then jump over to another system per se. I think this magma pathways here, the magma accumulation zone in the subsurface is near the power plant. And so you have a pretty efficient system for accumulating, storing magma, and bringing it to the surface. So I can't see a reason, and you know, we've talked about this before, like the Eldrup system over here that other geologists have said, oh, it's going to jump over there. I just don't see it. I don't see any reason to expect that. I'm not saying it can't happen, but I don't see why it would abandon this pathway that it's now created for, what, 6 eruptions. anytime soon. So hopefully that's a little bit helpful there, as just giving you some context. From Scott, where in the world to expect the next big volcano event like VEI 5 or higher, and aren't we overdue for one? Well, the overdue game is a tricky one to play because it depends on how you define things. You're also, when you say overdue, you're also assuming that volcanoes follow some sort of cyclical pattern, that like, oh, it's like being overdue for your taxes or something like that. Like something was supposed to happen on a certain date, and when we exceed that date, it's overdue. In terms of VEI 5 or greater, I mean, I would definitely not look to Iceland to produce that next eruption, although there are volcanoes that could. I mean, I guess the most likely candidates are out there in the West Pacific, right? And I'm not as familiar with all these volcanoes, but Indonesia, Philippines, Japan, Alaska, maybe New Zealand, like those are the more likely candidates. Definitely subduction zone volcanoes. That's where I would look if we're going to have a big eruption, VEI 5 or higher, which is a very explosive eruption in terms of how much volume of material it produces. I would expect it to be along a subduction zone somewhere. But it could be some other system as well. Okay, let's do... Yeah, we got one more question here. Let's see. Brian Rass wants to know, hey, Shawn, I do a lot of climbing on Mount Lemmon in Arizona. Do you happen to know when and how the granite and gneiss there came to be? Well, funny question, Brian, because I'll be down in Tucson this February. I haven't been there since I was like a teenager. I don't know the geology there that well. There's people like Elaine here on the live chat that live there that certainly know it better than I do, and hopefully I will get to do a little bit of climbing up near Mount Lemmon and maybe some mountain biking as well. We're also going to go to the Gem and Mineral Show. Basically, I mean, the big overall, in a nutshell, what you have in this part of Arizona, southeastern Arizona, is basin and range extension that's more or less oriented slightly southwest northeastish. So there's been a tremendous amount of stretching of the Earth's crust in this region over the last 25 or so million years, and that's why you have these mountain ranges, these valleys, and these mountain ranges. Now, complicating that a little bit is during all this extension, you also had volcanic activity, so there's been volcanoes that have erupted in the region. So this is still very much part of the basin and range. But in terms of the individual geologic histories of each one of these mountain ranges in detail, that's something I'm not as familiar with. So the granite and gneisses, though, are undoubtedly, well, I shouldn't say that, are probably related to the extension bringing up these very old, high-grade metamorphic rocks like your gneisses. So those gneisses would have formed at depth, and then as we extend the Earth's crust, we can bring up along normal faults, low-angle normal faults, what we call detachment faults. We can bring those rocks up to the surface with large magnitude extension. So that's my best take on it, but again, I don't have a good intimate knowledge of the geology around Tucson, so unfortunately I can't go much further than that. Okay, one more question sheet here, question sheet number 3. Thanks for sending these in, team. Hopefully everyone's doing okay. Take a drink of water. Maybe I'll do that myself just real quick and reset. All right. Question number 3, Ryan M. just dropping into the chat. Good day. Have you ever done a long-form video of Newberry volcano? It's a super weird shield volcano near my home. I've not done a long-form video at Newberry. I was kind of running out of time last spring when I did the Crater Lake, Mount Lassen, some other places, and by the time I arrived at Newberry, I didn't have time to do a whole lot, and so I just did a pretty quick video on the big obsidian flow that's there. So I have not done a long form video on Newberry, but holy cow, you could do a lot of stories and filming around there. It's a cool spot. Kate Bat wants to know, have you ever been to Santorini, Pompeii, or Herculaneum? That's in Greece. I do know that much. Or Pompeii, I guess, Italy. Everyone goes for the archaeology, but the geology is pretty damn impressive as well. I really want to go, Kate, so if you are buying me tickets, let's go. I would love to go over to that part of the world. Definitely on the list, but I have not been to that part of Europe. From Volcano, enabling 3D video or 3D buildings will give you a high resolution terrain model in regards to the lava color question. Oh, well, let's try that real quick. So if we go back to Iceland, thanks for the tip. I'm a Google Earth user, but not a pro, that's for sure. So if we come in here, well, it depends on which one you have. I have Google Earth Pro, and mine doesn't have, I don't think, does it have a 3D option? I don't think it does. But I have seen that on the web-based version. So, yeah. Enabling 3D buildings. Oh, that's probably in my tools, right? Now I'm just doing this in front of everyone and probably looking silly. Let's see. 3D buildings, building highlights. Oh, 3D view. Is it on this? No, I'm not seeing it. Okay, good tip nonetheless, and I will look for that somewhere. And maybe I'm in the wrong option here. No one's chiming on the, no one's shouting on the live chat to do one thing or another, so probably okay. All right, next question from Alan DeMars in Jerome, Idaho. Is there any chance that the formation of the Snake River Canyon was accelerated by residual rhyolitic plumes rising under certain sections of the canyon? Well, the two different things going on there, Alan, now that we're going to jump back over to Idaho real quick for those of you keeping track. Oh, and thanks, Elaine, for your kind donation. Much appreciated. Hope you're doing well. So Alan wants to know here. So here's the Snake River Canyon cutting across southern Idaho. Here's one of the cool pathways of the Bonneville flood, this scoured out section of scabland right here where there are no farm fields. But Alan's question is there any chance the formation of the Snake River Canyon was accelerated by residual rhyolitic plumes rising under certain sections of the canyon? No, because the rhyolite precedes the canyon by, I don't know, several million years at least, Alan. The rhyolites are erupting and forming at a time and on a landscape at a time well before the Snake River Canyon as we know it, and without any river system or canyon even here. So there's not really any. That being said, the Snake River Canyon, like any waterway, potentially has some controls to it, meaning that when you look in the subsurface, there's sometimes weird, rivers will follow weaknesses. It could be a fault line, could be fractures, could be a contact between two dissimilar rock types. So they will exploit weaknesses as river systems develop. And there is some interesting relationships such as here that I haven't been able to figure out. So if we look at the Snake River Canyon here, and this is the Devil's Corral area in here, there's this north-south trending, and this is like a canyon, right? So there's water running through this, and then this intersects this east-west one here. Now all this was scoured out by the Bonneville flood, but the Bonneville flood was moving from east to west across here, and that doesn't explain this north-south little paleo valley that is in this direction. So I'm not sure what to make of that. Here's another similar feature here. So you see how we have some of these north-south little valleys that run across this landscape here. You could really even almost just line these up per se. But these are all in volcanic rock, so it doesn't make sense to me that you'd have these linear controls that look like structural faults on there. So I don't know if that was helpful or not, Alan. We could probably discuss later sometime. Jim Sadler, do the cumulative fissure eruptions widen the Atlantic Basin to any degree which is measured by GPS? Okay, so back to Iceland for that. Yeah, and then we got a couple more questions, and we'll round this out with two more questions, team, if that sounds good. So is there, Do the cumulative fissure eruptions widen the Atlantic basin to any degree which is measurable by GPS? I don't know, but I would think not. The fissure eruptions are you've got to create space, so there is earthquakes generating space for the magma to come up, but the fissure eruptions are generally quite a bit more narrow. Like if we look at this old one here, this older lineament of fissures and cones, that's much narrower than when we look at the more tectonic scale, like Graben features. Like if we come up here to like Thingvellir or something like that, where you have an entire valley that runs from, you know, from here to here. Like I don't know if this will work either. Let's try one more of these. Yeah, I didn't go far enough that way. Does it allow you to pull the point further? Oh, that's kind of nice. Yeah, so there's sort of the idea, right? So then we've got this downdropped graben that sits along this plate boundary, which is 10 kilometers wide here. So yeah, so I don't know. Definitely, I don't think the fissure eruptions widened the Atlantic basin because there's such small volcanic features. It's the bigger tectonic faults and grabens that over time will be more substantial and more noticeable. From Apisto, how does basalt become amygdaloidal? Yeah, so that fancy word there, maybe I should put that on the screen in case anyone wants to know what the fancy word is. So how does basalt become, there you go, right here, amygdaloidal? So the idea is we start with basalt that has gas bubbles in them. So vesicles, there's already pre-existing gas bubbles in our basalt. The lava has cooled and completely crystallized. The basalt is there. It's just a rock. And then we allow groundwater to pass through that basalt. And in those vesicles, in those pore spaces, in those bubbles, we precipitate out of the groundwater some sort of mineral coating or lining inside of it. I'm trying to see if I have one on my shelf I could show you. I don't see one right there. And that will form these amygdaloids, or amygdules is actually the proper way to pronounce it. So, and maybe I can pull up a quick picture if anyone's interested. Amygdule basalt. Let's see if there's a good picture just on the internet. Yeah, Wikipedia. Good job. So here is a picture of one of these things. So here is your basalt, and you can see some of the bubbles are still open, right? They're still voids, but many of them are filled in with, and you can see they're very rounded, right? Most of the bubbles are fairly rounded, which is common in basalt, but a lot of them are completely filled in with mineral material. Some of them just have a little lining around the rim. Others are completely filled in all the way through. So in a nutshell, amygdules in basalt form as water carrying minerals moves into the basalt and precipitates or deposits a thin rind and eventually more of that mineral material into the void. And that's how you get amygdules. So glad I could help with that one. There's a few there that were stumping me. Okay, last question from Mr. Manlet. Is it likely that Three Sisters will erupt again at some point in the future? Absolutely. Who knows when, but at some point in the future, we will definitely have an eruption from one of the Three Sisters in Oregon, probably the South Sister. So if we buzz back over on our transatlantic flight over to the Cascades, there's a South Sister, the Middle Sister, and then the North Sister. So we have these three somewhat coalescing big volcanoes here. Let's see, let's go the other way. Kind of on the skyline. So if we kind of come down and look up, let's give them more of their kind of due there. There we go. So North Sister, Middle Sister, and the South Sister. And from what I know, which is somewhat limited on these volcanoes, I believe the South Sister is the most active. Historically, it's the one that has shown signs in the last 20, 30 years. Small little upticks in earthquakes activity or magma movement in the subsurface. So I think this one is the most likely of the three to have an eruption sometime soon. Sometime soon being what? Well, sometime soon could be tomorrow, or it could be, another 100 years or so from now. Broken Top, I think, is pretty eroded. I think that one's less likely, but these three here, and this one in particular, shows more recent signs. And if we get rid of let's see if we can get rid of the snow on it and pick a different time frame. Well, that's not good. There's kind of always snow on it, right? There, that's a little better. Oh, darn it. Picked the wrong one. There we go. You can see some of the young lava flows that have broken out from the walls of this volcano. So here's a thick, sticky lava flow. You can see the kind of ropes and the lines in here. This may have some obsidian in it. I'm not sure. Here's another one here. A little bit of a fissure maybe system right here. Another little one there. So these like these little lava coulees that have formed. And I don't know the ages on these off the top of my head, but they're youngish, right? They have not been modified by glaciers and such. So, and there's a little crater at the top. Little summit crater on South Sister. So yeah, definitely potentially active. So okay, how'd we do? Was this helpful? Was this informative? I hope so. Hopefully folks enjoyed that. Yeah, and for me, this was mainly about just getting our little community back together. Answering questions is always good. That's what I'm here for. But getting folks to chat and just reconnect and just kind of reestablishing it. We hadn't done one since last month, so I wanted to do another one. So looking forward into the crystal ball. Hopefully we'll be able to get something going with Nature Eye, so potentially look for a live stream with a drone flight. If you have a specific spot you want us to fly over, maybe send that as a suggestion. We'll see what we can do. Depends on access and weather and some of those sorts of things. But look for that. Look for some more of the Geology 101 videos. I've got one more video from the Dinosaur Monument area in the hopper that I'll get out probably this week. And then this weekend, I got to pick at least one day this coming weekend and get out and probably just locally and get some more videos done just to get some more things in the queue. But I'll get some more of those done. We'll continue to do our updates on Iceland, on Kilauea, on any activity we see in the Cascades or other volcanoes that I follow and have some vested interest in. So, but yeah, this was great. I appreciate everyone for jumping on here. Thanks as always to Amanda Jo and her help all around. Also to Susan. I hope everything's well with Susan. She was riding out these big two nasty hurricanes in Florida, and she lost power for several days. It was pretty touch and go, but luckily she's okay. I think her home's okay. There's not much damage there, but not the same scene with everyone there. So we wish the best to those that were affected there. So good stuff, team. Yeah, field trips, look for those. Check out the website. Again, the website is willseygeology.com, and Amanda Jo keeps that thing humming. We'll get more field trips up there for you sometime soon. Also hoping to get back soon some of the logos for the merchandise, and when I get some of the logos and graphics back, I'll try to share those with you, because I want you guys to have as much of a say in what is picked and chosen as I would, because I don't really have a good eye for that sort of thing anyway. So with that, we'll go ahead and sign off. Thanks for your time. Thanks for your support of the channel. It's so much appreciated. I hope you're well. Hope you're learning geology and enjoying it. It's keeping your brain and your body active as best possible. And we'll continue to see you out there. Appreciate it, and take care, friends.